Hydrocarbons are organic compounds that contains only carbon and hydrogen. It can be classified into aliphatic and aromatic. The aliphatic hydrocarbons are divided into three major groups, which is alkanes and cycloalkanes, alkenes and cycloalkenes, and also alkynes. For the aromatic hydrocarbon, it must contain an aromatic ring. It is also called as a ring. Benzene is one of the examples of aromatic compound. So cycloalkane and cycloalkenes are not considered as aromatic compound because it has no aromatic ring. We will discuss about the aromaticity further in chapter 6. If a hydrocarbon contains only carbon-carbon single bond, it is said to be saturated because it has the maximum number of bonded hydrogen atoms. If the hydrocarbon contains the multiple bond, it is said to be unsaturated. So alkenes and cycloalkenes are the example of saturated hydrocarbon, while alkenes, alkynes, cycloalkenes, and even arenes are the examples of unsaturated hydrocarbon. An open chain alkane has the general formula CnH2n plus 2, where the number of carbon must be equals to or greater than 1. Straight chain or unbranched alkanes have their carbon atoms joined together in a single chain without any branching. The first part of the name will indicate the number of carbon atom and it will determine the parent name, while the suffix "in" indicates that it is an alkane family. The groups attached to the main carbon chain are called substituents because they are substituting hydrogen atoms on the main chain. Examples of substituent are alkyl groups. So alkyl group is a carbon substituent that is bonded to a long carbon chain. It is formed by removing one of the hydrogen from an alkane. Alkyl group are named by replacing the "-ane" suffix of the alkane with "-il". For the branched alkyl group, the numbering will always begin at the point where the group is attached to the parent chain, which is the main carbon chain. For example, if we have 3-carbon alkyl group, the carbon that is directly attached to the parent chain is going to be carbon number 1, and then the carbon next to it is going to be carbon number 2. Here we can see a methyl group is attached to the carbon number 1. So this methyl group is going to be the branch of this alkyl group. Thus, the name for this branch alkyl group is going to be 1-methyl, right? So because the methyl is attached to the first carbon, and then the longest carbon chain for this alkyl group is 2 carbon, so it's going to be ethyl. The other name for this branch alkyl group is isopropyl. Let's have a look at an example. Okay, so let's say we have a branch alkyl group attached to the 4th carbon, right? So how do we know that this is a branch alkyl group? Because the carbon that is directly attached to the 4th carbon is going to be the first carbon, and then the carbon next to it is going to be the second carbon. So since these two carbon are symmetrical, it doesn't matter where you put the carbon number 2. So let's say I'll put the carbon number 2 here, and then from this numbering, we can see that our alkyl group got a branch. Okay, so we have 1 methyl attached to the first carbon. Okay, so this is an example of the 3-carbon branch alkyl group. Okay, so the parent name, since it got 7 carbon, longest chain, the parent name will become heptane, and then the substituent, it is attached to the 4th carbon. Okay, so we are going to use a bracket to indicate that our alkyl group that attached to the 4th carbon got a branch. Okay, so since we have a metal attached to the first carbon for our alkyl group, okay, 1 methyl, and then the longest carbon chain for our alkyl group is 2, so we have ethyl. Or we can just simply use the for isopropyl. Right? So to write it down as a single word, the IUPAC name of this compound can be 4,1-methyl ethyl heptane or 4-isopropyl heptane. So these two names are acceptable for the IUPAC nomenclature. For the 4-carbon branch alkyl group, if the longest carbon chain of the alkyl group is 3 and then it got one substituent, right, which is the methyl group attached to the first carbon, the name of this structure is 1-methyl-propyl or SAC-butyl. Another one, if the methyl is placed on the second carbon, the name will become 2-methyl-propyl or isobutyl. And the last one, if the longest carbon chain for this 4-carbon branch alkyl group is 2, and then there are 2 substituents are placed on the first carbon, the name of this structure is 1,1-dimethyl-ethyl or it can be 3-butyl. And last but not least, for the 5-carbon branch alkyl group, if the longest carbon chains are 4 carbon and then the methyl is placed on the first carbon, the name of this structure is 1-methyl-butyl or SAC-pentyl. If the methyl are placed on the third carbon, okay, the name for this structure is 3-methyl-butyl or isopentyl. If the longest carbon chain is become 3 carbon and then 2 methyl are attached on the first carbon, the name of this structure is 1,1-dimethyl-propyl or 3-pentyl. But if the 2 methyl are placed on the second carbon, the name of this structure is going to be 2,2-dimethyl-propyl or neopentyl. There are 3 main steps that must be followed in order to name an alkane. The first step is find the longest carbon chain. So the longest carbon chain is going to be our parent chain or the main carbon chain. For example, for this compound, okay, this root, it can be our longest carbon chain. Since these 2 carbons are symmetrical to each other, so it doesn't matter if we choose this root or this root. Okay, so let's say I'll choose this root as my carbon longest chain. Alright, since it got 6 carbon longest chain, so the parent name is going to be hexane. Okay, hex because it got 6 carbon, and because it's come from an alkane family. So the second step, we are going to number our carbon main chain. Okay, so for this compound, since it's only got one substituent present, so we are going to give this substituent the lowest number as possible. So we can either number our carbon from left to right or right to left. So since we are going to give this substituent the lowest number, we will number the carbon from left to right. So now we know the position of our substituent. So the substituent here is an alkyl group and it only got 1 carbon, so it is a methyl group. So the substituent is placed on the second carbon. Okay, so since we have the methyl group, it's going to be 2-methyl. Alright, and then last step, we are going to name this compound in a single word. So use the hyphen to separate the number from letters and separate the numbers from numbers by using comma. Alright, so for this example, okay, so we are going to put the substituent on the front. Okay, so we have only one substituent, so it's going to be 2-methyl-hexane. So the number are separated from the alphabet by using the hyphen, and all the letters must be written without spacing. If there are 2 longest carbon chain of equal length, we are going to pick the one with more substituent. For example, here we have 2 roots, which is the orange root and the blue roots. Okay, if we focus on the orange root, okay, so this longest carbon chain will give us 2 substituent, while if we choose the blue root, it will only give us 1 substituent. So in this case, we are going to choose the one that gives us more substituent, which is the orange root as our carbon longest chain. And then next step, number our carbon longest chain. Okay, so we are going to give the first substituent the lowest number. So in order to do that, we are going to number it from left to right. So since the longest of carbon chain is 6 carbon, so the parent name is hexane. And then here we have two different substituents. Alright, so on carbon number 2, we have metal. And on carbon number 3, we have ethyl. So to write down the IUPAC name of this compound as a single word, okay, so we are going to start with substituent first. Okay, so since we have two different substituents, we are going to arrange it in alphabetically order. So since E comes first before M, we are going to write ethyl first. Okay, so 3 ethyl and then 2 methyl hexane. If the first substituents are in the same distance from the both ends, we are going to number our carbon main chain to give the next substituent the lowest number. So for example, here if we number it from right to left, the first substituent is on carbon number 2 and the second substituent is placed on carbon number 3. But if we number it from left to right, the first substituent is still on carbon number 2, but then the second substituent falls on carbon number 5. So between 3 and 5, 3 is the lowest number. So we are going to number our carbon longest chain here from right to left. So since the longest carbon is 7 carbon, so the parent name is heptane. And then the substituent, we have 2 metal on the second and 6th carbon. So since these two are the same substituent, we are going to use the prefix di to indicate that there are 2 metal on these 2 carbon. So if there are identical substituent present, 2 identical substituent, use the prefix di. If we have 3 identical substituent, use the prefix tri. For 4 identical substituent, use the prefix tetra. And then our next substituent is the branch alkyl group. So we have a branch alkyl group. So the first carbon is going to be the carbon that is directly attached to our longest carbon chain. Okay, so this is the first carbon and then this is the second carbon. So since we have 3 carbon branch alkyl group, okay, we can name it as isopropyl. Alright, so since the isopropyl is placed on the third carbon, so we have 3 isopropyl. To write the name in single word, okay, so we will start with our substituent first. So the word iso is considered as a part of alkyl group for alphabetizing purpose, while the prefix dies aren't. So to write down the IUPAC name for this compound, so since I is comes first before M, so the name of this compound is 3-isopropyl 2,6-dimethyl heptane. If the location of two different substituents are the same from the both end of the carbon main chain, we are going to assign the number alphabetically to the first substituent. So since our substituent here are chloro and metal, and C is come first before M, we are going to give the chloro the lowest number. So in order to do that, we are going to number our carbon main chain from right to left. Right? So since the longest carbon chain is 6, the parent name is hexane. Okay, and then the position of the chloro is on the second carbon, so we have 2 chloro, and then the position of metal is on the 5th carbon, so 5 metal. So to write down the IUPAC name of this compound as a single word, okay, same like previous example, okay, we are going to put the chloro in front because C is come first before M. So the IUPAC name of this compound is 2-chloro-5-methyl-hexane. So the halogen group is for the haloalkane compound. But to name an haloalkane, we are going to put the halogen group as substituent. Okay, so if we have fluorine, it will become fluoro, chlorine, chloro, bromine, bromo, iodine, iodo.